Yes, today we'll be solving LeetCode number 1752. Check if array is rotated and sorted. This is an easy question on LeetCode, and it is also the daily problem for today. Now, let's get to the question very quickly. The rotations. Okay, I'll explain rotations very briefly, although I've explained them for probably like 5 days in a row now because all daily problems have been rotations. Rotations just mean if I was given 1, 2, 3, 4 and I had to rotate it once, then think of it like a circular motion, and we would essentially shift everything in the array by 1, just like this. X is equals to 1, right? And that's really it about rotations themselves. This question itself asks about if the array is rotated, right? If the array was rotated, what is the guarantee that it was sorted originally, in the sense that like we take 1, 2, 3, 4, right? And if we rotated it, let's say 2 times, so 3, 4, 1 and 2, if we unravel this essentially and we came back to this, what version would we get? 1, 2, 3, 4, and that has to be sorted. That's essentially it. And if it wraps back to that, then it is true. But the question itself can be solved without looking at this specifically, and this goes down to the things that we did in binary search yesterday. Let's consider the example over here first. Okay, 3, 4, 5, 1, 2. This is expected to be true, and let's see why. So let's consider the values in the array. 3, 4, 5 sorted, there's a drop, and then it's sorted again. Now let's consider 2, 1, 3, 4. Okay, there is essentially it is not sorted and then it is sorted, right? We have a drop over here, right? And then we have a sudden increase over here. Don't worry about the sudden increase, but we had a drop, right? And the portion after the drop as well was not uniformly sorted, unlike this example over here where there was a drop and it was uniformly sorted right after. And let's consider 1, 2, 3. That one is just sorted in an orderly fashion. We don't have any issues with that. But this was expected to be false, right? And it should be false, because if we unravel this, any way possible, actually any way possible is not even the question. 2, 1, 3, 4. If we consider this to be rotated 0 times, then it was not a sorted array, right? It is not a sorted array. So how did we determine, right? How do we determine whether it was sorted or not? And that is simply just to count. Okay, when you check an array, whether an array is sorted, you can, if I've given you this, let's say 8, 7, then I've given 9, 10 and 4, right? How do you check an array? You go 8, you check 7, you check 8 with 7, and you see that it is decreasing, right? There's a drop over here. 7 to 9 you're happy, 9 to 10 you're happy, 10 to 4 you're not happy, right? What paths caused a specific problem? 8 to 7, 10 to 4. Over here, what path caused a specific problem? 2 to 1, right? 2 to 1, we noticed, hey, it dropped, right? And if we consider this to be circular, now this is the trick, by the way. If we consider this to be circular, then we would be comparing 4 with 2 as well, and we would see, hey, that also dropped in value, and we're not happy with that. And since we're told, like, if the array is sorted, right, if it is sorted, then we rotate it. There is a common theme amongst them, is the fact that all of them will follow this pattern. So the one after the drop, there will only be a singular drop. If we consider 2, wrap it around 3, 2 and 3, that is increasing, right? We are happy with that. And so if an array is actually sorted, right, and it was rotated, then we would say that it would have been originally sorted if the number of drops, essentially the number of drops, like the number of these x's over here was limited to 1. Why limited to 1? Because, well, if you had it sorted and you rotate it any number of times, let's say even 3 times, right? If you rotated this 3 times, sorry, not consider this, that's wrong. Let's rotate it 3 times now, 4, 3, 2, and 1. We would still see that, hey, there's only one drop, and if we consider the circular version, I don't know why I did that, it would be 1 and 4, and that is still an increase, so that's not a drop. So we notice that there will only be one drop, right? So let's determine a single reason as to why this would be true. It would be essentially because the number of drops that we have is less than or equal to 1. Okay, it can be 0 because that would mean that it is a completely sorted array, right? 1, 2, 3, 4 has no drops. Now let's figure out the number of drops actually. So let's start off with the value drops equals to 0, 1 first, and let's just do a single normal iteration through the array. Alright, we set up a normal loop. And how do we check the drops? Well, just compare I and I plus 1, right? The value and the next value. That's literally it. So all we need to do is compare nums I. And when is it a drop? Well, the one that is after us is less than us. So we are greater than nums I plus 1, right? And like I said, we had to check it in a circular fashion as well, right? A circular fashion. So the last index we would end at would be n minus 1, correct? Right? N minus 1 would be our last index. Let's add 1 to that, right? Like we were supposed to for this over here. And how would we go back to 0? Well, we would just modulo it with the length. So it would essentially be like n minus 1 plus 1 modulo n. So n modulo n, that's just 0. That's like saying 2 modulo 2, right? So if we just do modulo n now, and let's consider n to be len nums, just to make it simpler, right? And we will count the number of drops if that did happen, and at the end we will just see whether it is less than or equal to 1. So this is the best approach, O of n perfect solution. This is what I got after looking at the question. The one that I originally came up with was O of n squared as well. This one, essentially what I did for O of n squared was I took the same approach, so 3, 4, 5, 1, 2, and what I did was, as soon as I detect a drop, so nums I is greater than I plus 1, right? We had a drop, and what I would do is I would run another loop from j in range I plus 2 onwards, right? And I would do that, and I would just check whether the portion of that array is sorted. If it is not sorted, if that portion is not sorted, I would return false. Then the other thing that you can notice is 3, 2, 2, 4. Let's compare them. So like I said, 2 to 3 we are happy, but 4 and 2 we are not happy, right? That's decreasing. So we can just check. Once I notice the dip, that means there was a drop, right? That would mean that there is a chance that it is, there is 100% chance that it is rotated. So the next thing that we can check once we are outside of the loop, well, is just check if nums 0 is indeed less than nums minus 1. Not indeed, so let's do the opposite so that we can return false immediately. At the end I would return true, and I would run this for I in range len nums minus 1, and that was it. So that was the O of n squared actually right here. And then you essentially identify that you don't really need this, right? Because at the end of the day, what were we trying to do when I mean, not what I was trying to do, but what was I thinking? What I was thinking was, well, I started off with the same idea drops, and I was like, okay, if it's not sorted, we can return to false. But if we just count the number of drops as well, it is a lot easier. So you don't need to have this inner loop over here, nor do you need to have this, because you can just wrap this around with modulo actually. So that's what I learned, and that was